Previously, we covered the core foundations. Now in Part 5, we tackle how two rival teams proved a black hole sits at our galaxy's center. Part 5. What Sagittarius A teaches us about all black holes. Just orbital dispatch. Script Mamal. How two rival teams proved a black hole sits at our galaxy's center. Part 5. What Sagittarius A teaches us about all black holes. Hook. In the last 4 episodes, we followed two rival teams as they tracked individual stars around an invisible point at the heart of our galaxy, and confirmed that something 4 million times the mass of the Sun sits within a region smaller than our solar system. But the story doesn't end with that confirmation. The real question is what it tells us about every other black hole in the universe. Intro, recap, bridge. Last time, we looked at what Sagittarius A is still trying to tell us, the unanswered questions that remain despite decades of observation. Today, we're pulling back further. If Sgr A is the black hole we know best, how far does that knowledge actually reach? Section 1. A calibration tool for the universe. The Genzel-Ghez teams did something that sounds straightforward, but is genuinely rare in astronomy. They measured, directly, how stars orbit a central mass, not inferred, not modeled from statistical averages. Actually measured, star by star, year by year. That gave us a precise mass-to-orbit relationship, a reliable anchor point. And that anchor matters enormously when astronomers turn their attention to other galaxies. At distances of millions of light years, you cannot resolve individual stellar orbits. You're working with averaged gas velocities, statistical distributions, and indirect signatures. But if you've already verified your methods against a system where you can see the orbits directly, your confidence in those indirect measurements increases substantially. Sgr A effectively became a calibration reference, a known quantity against which other galactic nuclei can be cross-checked. Section 2. Why our black hole is so quiet. Here's something that doesn't get enough attention. Sagittarius A is, by any standard, remarkably subdued. It is not producing powerful jets. It is not blazing as a quasar. For its mass, it is extraordinarily underluminous. The reason comes down to accretion rate, how much material is actually falling onto it at any given time. Sgr A is starved. The gas and dust near the galactic center simply isn't feeding the black hole efficiently. When material does fall in, much of it is expelled before it crosses the event horizon, or it drifts in so slowly that it barely registers. Compare that to the centers of galaxies hosting active quasars or producing relativistic jets. Those black holes are consuming material at far higher rates, and the energy released in that process is what we see as luminosity. Sgr A's quiet state gives astronomers a useful baseline. It represents one end of a spectrum, a massive black hole in a low-activity phase. Understanding why it's quiet and what conditions would change that sheds light on why some galactic centers are violent, and some, like ours, are not. Section 3. What the rivalry produced. It's worth pausing on what the competition between these two groups actually achieved. Two independent teams, using different telescopes, different instruments, and different analysis pipelines, arrived at the same conclusion through different routes. That's not a footnote. That's the mechanism working correctly. Each team's results were sharpened by the knowledge that the other was checking the same numbers. Errors that might have survived a single team effort were caught. Methods were refined under scrutiny. The final picture is more robust precisely because it was contested. That model of rigorous, independent verification is what gives the Sgr A result its weight. And it's the same standard the next generation of questions will need to meet. Closer. Sagittarius. went from a radio anomaly to a confirmed black hole to a calibration reference for the wider universe, not through a single breakthrough, but through decades of careful, competitive, cumulative science. That's how this field moves forward. Next episode, Part 6, explores the next key question, and it's one that pushes the science into genuinely new territory. If you found this series useful, subscribing is the straightforward way to follow it through. That is Part 5 of how two rival teams proved a black hole sits at our galaxy's center. In Part 6, we explore the next key question. Subscribe so you do not miss it.